trying to explain conceptual question number 10. And in conceptual question number 10, we have an unknown charge, and they give us the direction of the force, the direction of the movement of the charge, and also the magnetic field. And we're just trying to show how the right-hand rule works in this illustration. So here we know that the current around this coil goes in this direction. So if I use the right-hand rule, this means that the current is going that way, and my fingers curl around this in this motion. So this means that the magnetic field is coming out of the page in this case. We also know from this setting that the electrons are going to the right direction. So by the right-hand rule, we know that this is for the direction of the electrons, this is for the magnetic field, and this is for the force. So we know that the magnetic field is coming out of the page. So this means it's going something like this, it's out of the page. And the electrons, or the charges in this case, are going to the right. So we will expect, if this charge was positive, for the force to be downward. But let's see what happens when the charges are negative, in this case electrons. So we can turn out the lights. So at first we just see the direction of the electrons. But once power is supplied, you can see that the force that the electrons are experiencing is upward instead of downward. And this happens because the electrons are negatively charged. And if I put enough of this, the electrons actually make a whole circle around it. And this circle can also vary in sizes. Thank you for listening.